Hi, this is Nagarjuna, and I'm going to discuss about the process control automation subject. So this subject is all about how to control a process using the automation tools. When it comes to the automation tools, we use a PLC. So PLC is one of the major component which is used in the automation sector. Or in another way, we can say it is a brain of an automation, right? So in this course, we will learn the automation related things in how to perform the programming for this automation, and we will also look into the some of the industrial applications, and also we will learn about the PLC programming in detail. We will learn all the switching applications, we will learn all the sequential applications, and then later on we will learn about the all the automation components like HMI, RTU, SCADA, and so on. So now let's look into the contents. So here in this first topic, we will start with the PLC. So in the PLC, it is nothing but it's a programmable logic controller. So we will look into the overview of this PLC, its hardware components, and also we will look into its IO modules. The IO stands for input output modules. And also we will see the concept of syncing and sourcing. Like if you want to interface a sensor to the PLC, so how to interface them, right? So this syncing and sourcing concept will help you how to connect or how to interface as sensors. Next, we will look into the programming. So one must know how to program a PLC, right? So here basically we use a ladder logic programming for our PLC, and ladder logic is one of the most simple programming. Like we can start writing a programming from the day one itself, right? It's very simple. Unlike the other programming languages, there is no difficulty at all. So easy to understand, easy to build the logic, right? So here we will learn the basics, and we will see how the program, the PLC is going to scan your program. And as I said, we will learn about the ladder logic and programming. In that we will see the bit instructions, and also the addressing. See, in ladder logic, addressing is one of the most important thing. So we will learn the significance of the addressing of the instruction in ladder logic. And then later on we will see the basic switching applications in this subject. And then after this we will learn about the intermediate to the advanced functions of the PLC, and here we use the timers and counters. When we use these timers and counters into the programming, it becomes a sequential, right? Unlike the in a previously we learned about the basic switching applications. In the basic switching application, like if the input is changed, immediately the output will change. There is no delay, there is no lag at all. Whereas in sequential programming, when input is changed, the output may change after some delay, or we can introduce some delay, or we can switch on the outputs with some events, or when a particular event is triggered, then we can turn the outputs. So these kind of applications will come under the sequential. So basically the programming divided into two parts. One is a switching application, the other is a sequential applications, right? So for sequential, timers counters will help a lot. So we build the application based on these two. Next, we will learn some sequential programming examples. And later we will learn analog PLC operation. See, analog PLC operation is one of the most important when we talk about the continuous process. Like for example, if you want to control some level, or you want to control some pressure or flow, all the industrial physical parameters, if you want to control them, then we need to know how to process an analog signal. Because using the discrete inputs and output, to some extent we can able to solve the industrial application, but mostly if you want to control these physical parameters, one has to know the analog signal processing. And then we will learn about the networking of PLCs, because in industry, like we will be using more than one PLCs, so we have to bring these PLCs into the network. And when you look into the large scale, like if you work with a SCADA, then we need to have these PLCs into the networks. So when these PLCs are in the network, then only we can able to communicate. These PLCs can able to communicate, and we can able to acquire the information. We can able to acquire the process or the field information through PLC to the next level SCADA. So the networking is one of the most important in PLCs. So we will learn all these concepts in this subject. Next comes to the applications. After going through the details of the overview of the PLC, after going through the programming, and now it comes to the application. So where we can use this PLCs. So we have figured out some applications for you. So firstly, in robotic applications, we how to use the PLCs. Next, PID control of continuous process. I was mentioning about the continuous process. Continuous process are like level, pressure, flow. All these things comes under the continuous process. So how to control them using PID? PID, it's a proportional integral derivative, one of the very popular controller in process. Then continuous bottle filling system. You all know that the bottle filling system is one of the in most of the chemicals in pharmaceuticals we use this type of process. Even in the beverages factories, manufacturing factories, we use this bottle filling, capping, like that. So we will see this application as well. Next, we have a batch mixing system, and then followed by 3-stage air conditioning system. All these applications are industrial applications. So all applications are unique, and we will look into all these applications in detail. We will try to understand this process, and we will try to solve the solution for them. And finally, the automatic frequency control of an induction heating, right? So for this, we need a VFD, variable frequency drive. So using the drive and how we're going to control this application, we will see. And then later on, we will see the PLC installation, troubleshooting, and maintenance. So how to maintain a PLC and how to troubleshoot a PLC if any problem occurs, how to diagnose and how to identify the fault. All these things we will learn in detail in this particular topic. Later, we will see the data communication. In the data communication, there are about more than 20 plus protocols available in the industries. To name few, CAN, Controller Aerial Network, and Profinet, Process Field Bus, like that. So there are so many protocols, but now I have listed I have mentioned I have just pointed few protocols which are very popular. So here we discuss about field bus, process field bus, and also the HART protocol. HART is very special. HART stands for Highway Addressable Remote Transducer Protocol. This is a very, very special protocol. We will learn about this protocol. Basically, what is the need of a protocol? See, protocol is generally it is used to communicate your field device to communicate between the field device to a controller, right? Or else from a controller to the next level. So for basically for communication purpose, these protocols will be used a lot. And there are some advantages by using these protocols. So we will learn and we will see all the significance of these protocols. Then we will also look into the smart transmitters, valves, and actuators. In the field, we use these actuators, we use these sensors, and so on. But what is the major advantage with the smart? So why we call them as a smart, and what advantage we get with the smart? So we will see all these things. Next, lastly, we will end this subject with the SCADA. So that is the last topic of our subject, that is the SCADA. SCADA stands for Supervisory Control and Data Acquisition System. What do you mean by supervisory? Supervisory means monitoring, right? So let's have there is a big plant, right? There's a lot of operations are going on. There are so many zones and there are so many fields. So manually monitoring all this process is not possible. So now we are in a digital era. So one can sit in a control room and he can able to monitor all the parameters, what is going on in the industry, right? So that's possible with the SCADA. So SCADA basically, it acquires the information from all the field devices, from all the controllers. There is a big network between the SCADA and the controllers. So from all the devices, the information will be acquired, and then we can monitor in a control room. And not only just monitoring, we can also interact with the systems, we can also change the parameters, we can also control them from the control room, right? So that's the main advantage with the SCADA. So the name itself is suggesting supervisory control by data acquisition. Then in this subject, in this topic, we will learn about the basics of the SCADA architecture, DCS versus PLC. DCS is the distributed control system, and SCADA communication protocols, tags, and so on, and applications of SCADA and IoT, industrial IoT. So all these topics we will learn in this course. So let's continue with our journey. So let's continue the topics in the next class. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.